In this video, we'll use the advanced 3 steps to sketch method to graph y equals tangent of 1/2 x plus pi over 4 plus 2. Now, before we jump into this method, let's go ahead and factor out our b term, which is the coefficient of x. And this will help us see our phase shift more easily. So when we do that, we factor out 1/2, and we're left with x plus pi over 2. Okay, you can always distribute that back through mentally. Make sure that you've factored out correctly, which we have. And then, of course, we still have the plus 2. So we'll work from this equation because it easily allows us to see our phase shift from the equation. Our phase shift can be found in here. So we see x plus pi over 2. That means we'll be shifting our graph to the left by pi over 2 units. It's a somewhat common mistake to look at the original equation and say that our phase shift would be pi over 4, but you have to find that phase shift taking your c term and dividing by b, or you can just factor out the b term and then you'll see your phase shift just like we talked about. So either way you prefer is completely fine, just make sure that you're consistent with it. Okay, so let's jump into our method and our graph. Here's our outline on the left and our grid. And before we get started, let's take a moment to write out the general form, which will help us identify all our pieces. So that's y equals a tangent bx minus c plus d. And remember, we did factor out our b term, and so we are actually working with bx minus c over b. All right, so starting with step 1, we will find the essentials. And we'll start with our base graph and identify a and b. So a is the coefficient in front of tangent, and in this case it's an understood 1. And that'll help us set our curve setting points. It'll help us find those y coordinates. Okay, b is the coefficient of x, like we've already said, so that's this 1/2 here. So this tells us a couple things. First, it tells us that we'll have 1/2 of a cycle happening between 0 and pi for our particular graph. It also will help us find the period, because to do that we should calculate pi divided by b. So in this case, pi divided by 1/2, that's like pi times the reciprocal 2 over 1. So our period in this case is 2 pi, or that's the length of one horizontal cycle. All right, now that we have that information about the base graph, we can choose how we want to label our axes. And so we're very intentional with the horizontal scale. Take your period and divide by 4, and that'll ensure that each of your points when you're making the base pattern in step 2 will align. And of course you may shift them off in step 3, but it'll keep everything nice and neat for your intermediate steps. Okay, so our horizontal tick marks will be labeled, we'll take 2 pi divided by 4, okay, which of course is pi over 2, and that's how we'll count those tick marks. For our vertical scale, we will use 1. So let's take a moment and label. We'll start with our horizontal axis, and we're counting by pi over 2. So we have 1 pi over 2, 2 pi over 2, which reduces to pi, 3 pi over 2, 4 pi over 2, which reduces to 2 pi, and 5 pi over 2. Now we can label the other side of this axis. It'll be the same values, just negative. So take a quick moment to do that. All right, and then we'll label our vertical axis counting by 1s. Easy enough. Now we have a little bit more essential information to find before we move on to plotting the base pattern in step 2. We first want to identify our shifts. So we said earlier, we find our phase shift by calculating c divided by b, or we can look at our factored out equation. So we see here x plus pi over 2, and we know that means we have a horizontal shift left pi over 2 units. And we know it's left because our general form equation is bx minus c, so to get a plus right here, it must be minus a negative value. So let's record that. We'll mark it as negative pi over 2 units, or if it helps you to write left pi over 2, you can do that as well. Okay, let's clear this up a little bit. We know that d is our vertical shift, and we see that plus 2 at the end of our equation. So D is 2. We'll be moving our graph vertically up 2 units. All right, and the final piece of essential information we should find is our asymptotes equation. And this will generate every single asymptote for your graph, depending on what value you plug in for k. So to find this equation, all you have to do is take your inputs of your tangent function and set them equal to pi over 2 plus pi k. So we'll do that now. We have 1/2 x plus pi over 2 equals pi over 2 plus pi k. And this is where k is an integer, so you would just substitute in 0, 1, 2, -1, -2, and so on. So now that we have this set up, all we need to do is solve for x. So let's first start by multiplying both sides of the equation by 2, which is essentially like dividing by 1/2. So we're multiplying by 2. Make sure you multiply every term by 2. All right, so on the left, we would be left with x plus pi over 2. And on the right, we have pi over 2 times 2, so that's just pi. And then we have plus pi k times 2, so that's now plus 2 pi k. All right, and then now all we have to do to isolate x is subtract pi over 2 from both sides. So on the left, of course, we're just left with the x. And on the right, we see only one of these terms as a like term for pi over 2. The plus 2 pi k is not a like term, so we don't have to worry about that one. So we just have pi minus pi over 2. You can rewrite it as 2 pi over 2 if that helps you. But when we subtract pi over 2, we end up with pi over 2 plus 2 pi k. So let's go ahead and write that in our asymptotes equation spot. X is going to equal pi over 2 plus 2 pi k. So for example, if you let k equal 0, we should have an asymptote of our graph at pi over 2. If you were to let k be 1, we should know we have another asymptote at pi over 2 plus 2 pi. Okay, well that's 5 pi over 2. And so this will just generate asymptotes depending on what value you plug in for k. There's a link in the video description if you want more details on how this asymptotes equations work. All right, so now we have all our essential information, everything is organized, and we're ready to put it all together. And we'll start by using the base graph in step 2, where we will plot the base pattern. And we want to make sure to do this lightly or in a different color because this will not be our final graph. All right, so our base pattern for an unreflected tangent graph is x-intercept, point, that's one of those curve shaping points, asymptote, and then another point. So let's go ahead and start. Here we have our first x-intercept on the origin. Remember, we're doing this lightly. We have our first curve shaping point at the first horizontal tick mark and a y-coordinate that's determined by a. So a is 1, so we put a light point at pi over 2, 1. Then we'll have an asymptote. Okay, and then our last point will happen at the third horizontal tick mark, and its y-coordinate will be the opposite of a, so -1. All right, let's go ahead and put another x-intercept at 2 pi. That would be the first point in the next cycle, but that'll nicely close off our cycle of our first cycle here. All right, so that's all there is to it. This is our base pattern, and we're ready to move into step 3, where we will shift, then sketch our graph and repeat. So change to your final color. I'm going to use green. And let's look at our shifts in step 1. So we need to be moving left pi over 2, which is 1 horizontal grid unit, and up 2, which is 2 vertical grid units. So for each of our light blue points, we will move them left 1 grid unit and up 2 grid units. And we can do this at the same time. So starting with the point at the origin, move it left pi over 2 and up 2. And we'll do that for each of our base pattern points. So then our curve shaping point that was at pi over 2, 1, move it left pi over 2 and up 2. The vertical asymptote moves left pi over 2, and moving a vertical line up doesn't really affect it. So that will stay at pi over 2, and that's great because that's what we were talking about when we made our asymptote generating equation. We should have an asymptote at pi over 2, and now here it is. All right, final curve shaping point, 3 pi over 2, -1. Let's move it left pi over 2, up 2. And our next point in the next cycle left pi over 2, up 2. So we can sketch in our tangent curve. All right, and here's one cycle of our tangent graph. Now the great thing about trig functions is that they are periodic or cyclic or repetitive. So once you have one cycle of the final graph, all you need to do is copy it over and over again. So let's repeat this cycle, and we'll start by going to the right. So we have our new point, 3 pi over 2, comma 2. We'll have a curve shaping point, and then another asymptote, just like we talked about. That asymptote will be at 5 pi over 2, and that's if we let k equal to 1 in our asymptotes equation. So we can sketch this in, and then we'll work in the other direction. So a negative curve shaping point or a lower curve shaping point. We'll have an asymptote. Try it out. If you plug in k equals negative 1 into your asymptotes equation, you should get x equals negative 3 pi over 2. All right, and then just working backward a little bit more, we see here is another tangent curve. So that's all there is to it. Check out the links in the video description if you want more examples, if you want more details about the asymptotes equation, or if you want to see some examples of other trig functions. Thanks for watching.